The average person checks their phone 96 times a day. That's once every 10 minutes you're awake. Not because you need to. Because a part of your brain that's older than language itself thinks something might be about to kill you, and it needs to check. It's wrong almost every single time. It checks anyway. Let's start with what that part of your brain actually is. Deep inside your skull, older than anything resembling human thought, sits a small almond-shaped cluster of neurons called the amygdala. Its entire job, for millions of years, across every species that has one, is threat detection. Movement in the grass, a shadow crossing the sky, a sound that doesn't belong. The amygdala doesn't wait for you to think about these things. It reacts first and lets the rest of your brain catch up later. This system kept your ancestors alive. It's also the system your phone has learned to exploit perfectly every single day. Here's the part that should unsettle you. Your amygdala cannot tell the difference between a genuine threat and a notification. A vibration in your pocket triggers the exact same alertness response as a twig snapping behind you in the dark. Your brain doesn't know it's a text message. It just knows something happened. And somewhere, something might need your attention right now. In 2012, researchers at the University of Missouri ran an experiment that revealed exactly how deep this goes. They separated iPhone users from their phones and had them complete simple tasks while their phones sat silent in the next room. Every so often, the researchers called the phone, letting it ring unanswered. Heart rate spiked, blood pressure rose, participants reported feeling anxious, and their performance on the simple cognitive tasks dropped measurably. Their bodies were reacting as if something was going wrong, because as far as their amygdala was concerned, something was. A source of information was calling and they could not check it. That unresolved signal is read by an ancient part of your brain as danger. But the amygdala only explains why you notice. It doesn't explain why you can't stop. For that, you need a different part of the brain entirely, and a chemical most people badly misunderstand. Dopamine. Most people think dopamine is a pleasure chemical. It's released when something good happens, so you feel good, so you want more of it. That's not actually how it works, and the real mechanism is far stranger and far more relevant to your phone. In the 1990s, neuroscientist Wolfram Schultz ran a series of experiments on monkeys that rewrote our understanding of dopamine completely. He trained monkeys to expect a reward, a small squirt of juice, after a specific light turned on. At first, dopamine fired when the juice arrived. Reward, pleasure, exactly what you'd expect. But as the monkeys learned the pattern, something shifted. Dopamine stopped firing at the juice. Instead, it fired at the light, the cue, the moment of anticipation. And here's the detail almost nobody talks about. When Schultz began skipping the reward randomly, delivering the light without the juice sometimes, dopamine release didn't drop. It spiked even higher. Uncertainty produced more dopamine than certainty ever did. Read that again. Because your phone was built entirely around this discovery, whether the engineers who designed it knew the neuroscience or not. Dopamine isn't about reward. It's about the anticipation of an uncertain reward. It's the wanting, not the having, that hooks you. And nothing in the natural world was ever engineered to deliver uncertain rewards as efficiently, as constantly, and as endlessly as a smartphone. Think about what happens when you unlock your phone and open an app. You don't know what's waiting. Maybe it's a message from someone you like. Maybe it's nothing. Maybe it's a video that makes you laugh. Maybe it's an empty feed. You cannot predict it. And that unpredictability is not a flaw in the design. It is the entire design. This exact mechanism has a name in behavioral psychology, and it predates smartphones by almost a century. In the 1950s, psychologist B.F. Skinner ran experiments on pigeons using a device called a Skinner box. Inside the box, a pigeon could press a lever to receive food. Skinner tested different reward schedules. When the pigeon received food every single time it pressed the lever, it pressed steadily, predictably, and stopped as soon as it was full. But when Skinner switched to a variable ratio schedule, food arriving after an unpredictable number of presses, sometimes 1, sometimes 20, something remarkable happened. The pigeons pressed the lever obsessively, compulsively, far more than the reliable schedule ever produced. This is the exact same mechanism that powers slot machines, and it is the exact same mechanism that powers the pull to refresh gesture on every app on your phone. You are, in a very real sense, a pigeon pulling a lever, and the lever is your own thumb, scrolling down to see if this refresh brings something good. Social media companies did not stumble into this by accident. Tristan Harris, a former design ethicist at Google, has spoken publicly about how these mechanics were deliberately engineered, drawing directly from casino design principles, applied to attention instead of money. The infinite scroll, the notification badge, the specific shade of red used for alerts, all of it tested, refined, and optimized to trigger exactly the dopamine anticipation loop that Schultz documented in monkeys and Skinner documented in pigeons. But there's a third piece to this, and it might be the most powerful one, because it isn't about threat detection or reward prediction. It's about something even older and more fundamental: connection. For nearly the entirety of human history, being cut off from your group meant death, not metaphorically, literally. A human alone on the savannah, without the protection, food sharing, and collective vigilance of a tribe, did not survive long. Your brain evolved inside groups of maybe 50 to 150 people, a number anthropologist Robin Dunbar calculated as the cognitive limit of stable relationships a human brain can actually track, now known as Dunbar's number. Every one of those relationships mattered enormously because your survival depended on them. Your brain still runs on those stakes. When a notification arrives, some deep, ancient part of your mind reads it as social information. Someone thinking of you, someone including you, someone confirming you still belong. And when you don't check, when a message sits unread, that same part of your brain reads it as a kind of danger. Am I being left out? Is something happening without me? This is why the fear of missing out isn't just a catchy phrase invented by marketers. It's a genuine evolutionary alarm, repurposed and firing constantly, for a threat that no longer exists in any meaningful sense, but that your nervous system cannot tell apart from the real thing. Put all three of these mechanisms together: threat detection through the amygdala, uncertain reward through dopamine, and social survival through connection anxiety, and you get something that isn't really a habit at all. It's three separate, ancient survival systems, each one individually powerful, all firing at once, dozens of times a day, every day, for years. Researchers have measured what this constant activation actually does. A study published in the journal Nature Communications found that heavy smartphone use correlates with reduced gray matter volume in regions of the brain associated with impulse control and sustained attention. Other research has documented something called phantom vibration syndrome, a phenomenon where people feel their phone vibrating when it isn't there at all. Their nervous system's so primed for that signal that it starts generating false alarms on its own. Your brain, quite literally, has been trained to expect the check. Here's what makes this different from earlier generations of technology. Television, radio, and print media had a start and an end. A show finished. A newspaper ran out of pages. Your phone has no bottom. There is no point at which the content stops and your brain receives a signal that says the search is complete. The threat is cleared. You can rest now. The scroll continues indefinitely, which means the ancient part of your brain that expects a resolution never actually gets one. It just keeps checking, because checking is the only response it knows how to give an unresolved signal, and the signal, by design, never resolves. This is not a personal failing. It is not a lack of discipline or willpower. You are not weak for struggling with this. You are a person with a brain built over millions of years to respond to exactly these three signals: threat, uncertain reward, and social connection, placed inside an environment engineered by extremely well-funded, highly intelligent teams whose entire job is to trigger those signals as often and as effectively as humanly possible. Blaming yourself for losing that fight is like blaming a pigeon for pressing the lever. Understanding the mechanism doesn't make the pull disappear. Your amygdala still can't tell a notification from a threat. Your dopamine system still spikes harder for uncertainty than for guaranteed reward. Your ancient need for group belonging still reads a silent phone as a kind of exile. None of that switches off just because you now know its name. But there is something that changes once you see it clearly. You stop mistaking the pull for a choice you're failing to make, and start recognizing it for what it actually is. Three ancient alarms, going off at once, in a world that never stops ringing them. Your ancestors built their entire lives around signals that eventually resolved. The predator passed, or it didn't. The tribe accepted you, or it moved on without you. Either way, the alarm went quiet. Yours never does. Yours never does. You didn't build the system that keeps it ringing. But now, at least, you know exactly why you keep reaching for it.